Heard about the garbage truck? Trying to stop you. Your message got through. How many of you have been stuck behind a garbage truck at some point? And smelly. Our quiz is today. Everyone excited? I see the excitement on your faces. You're gonna have to wait though. It's the last 30 minutes. It's a 20-minute quiz. So if you have extended time, then just be staying to the end. If you don't have extended time, you'll just be leaving at that 20-minute mark. That's how it goes. So let's just get right into it, shall we? Let's get through today's lesson completely. And we had to finish last time's lesson, didn't we? We didn't get to that special case. Let's see, what page are we on? We are on page 12. Let me close the door. Our last class for the week, isn't it? Let's make it good. Okay, so definition of m to the m over n. Let's remember that we know the a to the mn just kind of went away. Come on back. Come on back. Please work. Please. Let me replug and see what happens here. Please. Okay. Okay. Oh, here we go. I had to unmute it. Is user error there. Okay, so we know that this is equal to this, don't we? Or alternatively, we could also write it as a to the n to the mth power. Does it make sense that all these say the exact same thing? So we're going to play around with the a to the m over n in a similar fashion. Would you take a moment to write this two different ways? Just as I did with the a to the mn. You check in with your neighbor once you have an idea, or if you're really unsure about what to do. Oh, I'm gonna have you move over the. So if you count the three of you, or two of you, so you have. Okay, so a to the m over n could be written as, yes.
The n root of a to the m, right?
Oh, nice. But before that even, and how do you know nth root? How do you know we're talking about roots at all? We don't have any radicals here. What's that?
I've done this before.
Okay, cool.
I don't know like the logic of it.
Okay. But we're heading there, but you're absolutely correct. Yes, Haley.
A to the negative n.
Now, where did the negative come from?
If you're like doing the reciprocal.
Negative. I don't think I want to bring in any negativity at this point, but I think we could make it work. We could make it work. I'm looking for a different root here. Anyone have an idea? Yes. Yeah, that's what I'm looking for. What do you think? Does that make sense that we could think about it like this? That those two are equivalent. And I think like what you were saying, we could think about that one over n as a negative exponent, but that kind of that brings a added difficulty. So we can leave it like this: a to the 1 over n to the m, or
M to the a to the m to the 1 over n.
a to the m to the 1 over n. Do we agree that all these are equivalent? Cool. We have a visitor. Oh, yay, you made it.
Sorry.
No, I'm glad you made it. Traffic.
Yeah.
Don't tell her the secret to success on today's quiz. Just kidding. Okay, and now, like you said, what we talked about last time, a to the 1 over n, that's the same thing as saying the nth root of a. So we can rewrite this as the nth root of a, the nth power, or we could think about it as the nth root of a to the m. And these are equivalent. So when you see something like this, 27 to the 2/3, you could think about it either as the cube root of 27 squared or the cube root of 27 squared. Do you see how that follows directly from what I was saying before? Which one do you prefer? Discuss with your neighbor. How do you do these?
The first one. Right, so far, and then. Three, right? And then 39.
And one person vote for the first one. Let's vote. Do you vote first version or the second version? Okay, yeah. If you're a crazy person, you might vote for the second one because in the second one you have to do 27 squared first. Does anyone know what 27 squared is? It is oh, you're very close. Yes. It ends in a number. I think we can figure out. It doesn't matter what it is, though, does it? Because there's a much easier way to do this. We know that the cube root of 27 is 3, and then we know that 3 squared is 9. Yeah. Okay, now I do think that B is an error. So I'm gonna change this to 3/2. I'll give you a moment to work through B, C, and D. And check in with Vapor when you are done with those. Yeah. Maybe. Oh. Well, then you have other people around. Has no one finished up through D already? You're welcome to continue if you like.
I like did that, so not just this, and then yeah. I know how to see it. Maybe that.
You get all of them? Up through D, did you get them?
This one, yeah, it's. Sure.
Okay, ready or not, let's go over it. I do want to give you a little bit of a disclaimer. I don't know if I've warned you yet, but I will annoy you. Like I may just have annoyed you and by the fact that sometimes you'll ask me a question and I won't answer it. Sometimes well, more than often than not, I'll say, ask your neighbor. Figure it out together. If you and your neighbor don't know, then ask someone else. But I do believe that I'm a guide and I'm helping you through some new territory. But once we're in that new territory, I want you to kind of play around and see what you can figure out. Now, ultimately, if you can't figure something out with all the people around you, I will do my best to help you see your way out of the issues that you're having. But Yeah, so just so you know, that's coming. 9 to the 3 halves. When you see that's 2 on bottom, we're thinking of what? Square root. So we're thinking the square root of 9, then cube that, which is equal to 27. Do you think it's okay to go right from here to here? Sure. Once you know how to do it, why show that square root? You could take a square root of 9 in your head. I trust you to be able to do that. This one, who could help us with C? Because there's some negative action here that I think that yes, you figured out.
I think, would it be, the index would be 5, like the root 32, would it be 2 to the -2?
So the 5th root of 32 to the like this. Do we agree that this is equivalent to the problem? I love it. Yeah, let's keep going. Is that true? This is equal to 1/4? Nicely done. Yes.
Did you find what's sorry, the whole thing on your one, so like one. And then one. 5.
Oh, you did 5th root. 5th root. Yeah, that's how to say it. Like this. What do you think? Is this okay? That's great. Yeah, that is the associative property of multiplication, because in this -2/5, we could think about that as -1 times 2 times 1/5, or we could think about it as 1 times 2 times -1/5. Different ways to think about it. You gotta put that negative with it. So yeah, any way you think about it is fine, as long as you navigate it appropriately. Any questions? Okay, this one. What's the base of this 1/2? The base of 1/2 is just x. And the base of the 3/4, also just x, which means we're free to take the 5 and 7 and multiply them together. So we get 35 times x to the, what should I do with the 1/2 and 3/4? Add them together. How do we know we add them together? Yeah, that's a property of exponents that we know. A product of powers. You take those exponents and add them together. Do you know how to add 1/2 plus 3/4? I hope the answer is yes. I hope the answer is not, I need my calculator. 1/2 plus 3/4 is obviously 4/6. No, that's a joke answer. Was this 2/4 and then we got 5/4? Is that right? Yeah. Now let's see. It says write each expression in simplest form so all exponents are positive. Assume all variables are non-zero. So I think we have a little bit more work to do here. Yes, Lincoln, you know what to do.
Because the power is more, take out x.
Yeah. Yeah, let's examine this right here. Now we're dealing with, we're on the bottom, so we're dealing with 4th root. Now if I just put x on there, I don't know what the 4th root of x is, so I'm going to put that 5 inside. I'm going to use that second option here. And that's our job. You said, you got to simplify this. I need to find any perfect fourths inside here. Are there any perfect fourths? I think x to the 5th is x to the 4th times x, isn't it? And the 4th root of x to the 4th, what do you think it is? X. Is it x? Or is it absolute value of x? Yeah, absolute value of x. Boy. See the tricky ones here. F, I'm gonna skip E, trust you to be able to do that one. F, what happens at 25? It becomes a 5. What happens to the 4th? X squared, so x squared, and then becomes y cubed. And if you want to be safe, you want to put some absolute values around that. And that's really only necessary to put it around the y's, because x squared is definitely positive. We want to make sure that that's positive. We're taking a square root. Only positives can come out of square roots. Does it say anything about assume variables are not zero? So it's not assuming that variables are positive. That's why we put down the absolute values. If you forget it, the absolute value, it's a very, very small deduction. If you put an extra one for the quiz, it won't be a deduction. If you put an extra one, I won't deduct anything. Yes, Lincoln? We just want to make sure that we have positive numbers coming out of the square root here. So if x is negative, you square it, it's positive. So that's already positive there. But if y is negative and then you cube it, there's a chance that this quantity is negative. We want to make sure.
What is? This one.
Right, I won't deduct. I just want to see that you're thinking about it, at least for now. But I know it's a tricky part.
So is that the rule with all like even exponents, like, so like if it was like x to the 8th, you would only need to put it around the odd one?
Yeah, exactly. Okay, we got to get to today's stuff, polynomials. Before we talk about polynomials, we have to talk about a different word. Monomials. Do you know what a monomial is? You've heard the word, I'm sure, monomial, just in the streets. Maybe not in the streets, but maybe in a math class. Monomial is a number, a variable, comma, or the product of one or more numbers or variables. The way I think about it is a cluster of multiplication. So some examples of a monomial would be -8. Another one would be x. Another one would be 5x squared yz to the 4th power. It's a cluster of multiplication. Normally we only have one variable, but we could throw in other stuff to be a monomial. Not a monomial. Square root of x is not a monomial. Why is that? Yes. Yeah, it's not multiplication of a number of variable or many of those. It's a square root of a variable. It's just, and we could write this, of course, as if I said something like a 3x to the 1/3 y. It looks like a monomial, but it's not. It's that 1/3 that's perpendicular. So there are some imposters. Just be careful of them. Also, -4x to the -3rd power. Yes, Elise. The whole thing together has to be a monomial. It all has to qualify. But you're right. If this didn't exist, it would be a monomial. That x to the 1/3 didn't exist, but they're all held together. They're bound by multiplication. They can't be separated. -4 to x, -4 times x to the -3rd. Why is that not a monomial? It makes a fraction. We're dividing by an x here. This is not a monomial. So we're looking for positive exponents. They have to be whole numbers. Yeah, that's it. So, okay, that's a monomial. Of course, a polynomial, by definition, is a monomial, which is a little bit weird because poly means, as you know, poly means many. So it's strange that the start of the definition is that it's a monomial or the sum of monomials. And imagine that the word polynomial is not new to you. We're going to look just in a take a deep dive into it. And get some terminology going, just so we can speak the same language all year. It's important for you to understand me. Kind of key to learning. Okay, very quickly with your neighbor, discuss these four. Are they polynomials? We'll talk about degree in a moment, but are they polynomials?
I think it's the sum. So this sum. Okay, remember.
So this one, so it is, the one isn't. And that one isn't.
Okay, let's vote with our thumbs. A, what do you think is a polynomial? Heck yes.
Yeah.
How about B? Is it a polynomial? No, it's the negative one that's getting in the way. Nope. How about C? Is C a polynomial? I'm sorry, that one is.
Oh, they said.
Think about it. Square root of 2 is a number. It's on the number line, isn't it? It's a number. Don't hate the, what kind of number is square root of 2?
Yeah.
It's an irrational number, but it's still a number. So then we go to the other one. Is that z to the 7th a monomial? Yeah, it's a monomial. It didn't break any of the laws of polynomial, so it's fine. I know it's kind of the tricky one. How about D? Is that a polynomial?
No, it's not.
Remember the definition of
Oh, yeah.
polynomial is a monomial or a polynomial. So yes, it is, which is, I know, strange, but that's a polynomial. It's a little bit uncomfortable. Yes, Elise.
Why is it the square root of x on that number, but the square root of 2?
Because by definition, we're talking about monomials, so it's got to be a number or a variable. So like square root of x is a variable, but what's happening to the variable? We're taking the square root of it. So it's, if we defined something, if we define like a as a square root of x, then I guess a would be the polynomial a word, but just we're looking for very simply x, y, z, or any letter multiplied by the ones. How would you get a square root of x from here? I just can't. Yes. No, it's still a variable, but it's not a monomial. Well, the x part is a variable, but it's not no longer a monomial, and it's not part of a polynomial. It's called non-polynomial. That's the best we could do. But yeah. So in polynomials, we're just talking about variables with whole number exponents. And when I say whole number, can you show me what the smallest whole number is? The smallest whole number looks like a whole. The smallest number is 0. -3, is that okay for a exponent, for a variable? Not if you're looking for polynomials, no. In terms of degree, if you know the degree of A, could you show me what the degree is? Nice, the degree is 5 for A, I'm sorry, it's still up here. There are two different A's there, sorry about that. The degree here is 5. We always look for the highest degree, no matter what order it's in, it's the highest degree, 5th degree. B, oh yes.
What's a degree?
Degree is the highest exponent on the variable.
Okay.
So B does have a degree. It's not a polynomial. We're not going to give it a degree. And if you had to force a degree, we would say third degree, but we wouldn't even classify it as it's not a polynomial. C, seventh degree. D
First degree.
is a first degree.
Can't be zero.
If you had to force a variable into that, we would say that this is 5x to the,
Zero is anything with one.
Oh, so.
isn't that the same thing as 5? Pardon? 5, oh, because the degree comes from the variable associated with the highest term. So we kind of had to force a variable in here. If you say it's first degree, that means 5x, and that's just changing completely. So we could think about this as 5x to the 0 power, kind of, I hope you see what I mean by forcing a variable into it, because we know x to the 0 is 1, unless x, of course, is 0, but I think we're assuming here that variables are non-zero. I think it says that. It doesn't say that, but we could assume that. So yeah, 0 degree. Okay, so let's just do degree here. The first one we already know. I think you can do all those degrees, can't you? Go ahead and fill in the degrees. Check with the neighbor to make sure they got them right. And really, this is all you're doing here is seeing, are they paying the most minimal amount of attention? Because if they didn't get this right, I'm very concerned about the appropriateness of your placement here, to be quite honest. Okay, just show me the degree for A, for B, C. That's also 1. How about the square root of 5?
Not a variable.
Yeah, it's not a variable. We don't care. Well, we care about it, but not for degree purposes. For D, second degree. E, third degree. F. Man, that was difficult. Woo, working for a living here. Classified by degree. So every polynomial has a name. So we could call it 0 degree, or we could call it constant. A constant polynomial. Second one, we call it a linear. And you've heard that word with regards to math before. Like linear, basic linear equation is a form y equals mx plus b. Makes a line linear. So C, it is linear. Yay! Would you check very quietly to see if your neighbor knows what D is? On the count of 3, if you know it, I'd like to hear what you think. 1, 2, 3. It is quadratic. Does anybody here speak Spanish? Speak a little Spanish. Do you know how to say square in Spanish? I know it's not a word you use in normal conversation. What is it?
In class.
Cuadro. Cuadro. And how do you say x squared? X cuadrado. So I know that we think the word quadratic, we think, okay, 4. But square is associated with quadratic. And we're going to study those extensively in this class. So it's not a square equation, it's a quadratic equation or quadratic expression. E, any idea what that classification would be? Lincoln, you know? Cubic, yes. Which makes perfect sense, doesn't it?
I don't know, really.
No?
Oh, square and then cube.
Yeah, the square, the quadratic doesn't make sense based on x squared in our language. But it's for x cubed, it's a cubic. Everything is as it should be. F. It's not a fourth-dic. It's a quartic. Okay, by number of terms, any idea what A is? It has one term, so it's called a monomial. Normally we use two words to put these together. We would say a constant monomial. So B, is it really only one term? Yeah, it's a cluster of multiplication. That's a monomial. C, do you know what that is? Binomial. D, trinomial. Trinomial. E, yeah, polynomial of 4 terms. Many years ago, I tried to get those to be called Lieber monomial, but it did not take. I don't know why. So we would say it's a cubic polynomial of 4 terms, or with 4 terms. The last one we know is trinomial. So we would describe it as a quartic trinomial. Can you imagine a cubic binomial? Can you write a cubic binomial? Just check with your partner, see if they wrote an appropriate cubic binomial as well. So cubic binomial, let's hear it. What's one cubic binomial? Yes, Ben.
X cubed plus 4.
Are we good with that one? Awesome. Any others? Yeah, there's a billion others. We got stuff to do though. Thank you. Perfect. Okay. When you are, listen, you can perform operations on polynomials, and will it be appropriate to use like distributive property for A? No, distributive property happens when you are at multiplying. So this, you just combine like terms. I'm just going to do the first one to make sure we're okay. And maybe you can underline the like terms or something like that if you just want to be complete. I don't know. It's up to you. Completely unnecessary. But when you add these first terms together or the cubic terms together, you're left with 4x to the third power, right? The term doesn't change. It's just the coefficient that changes. I'm just going to put dot, 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 because we have stuff to do. B, you must be careful. Make sure your neighbor understands why you have to be careful. I heard it almost like a chorus. We have to take that subtraction and distribute it. So we have to think about this as minus 2x cubed, then plus 6x squared plus 3x minus 9. That is huge. And after that, am I done? After that, I'm gonna say dot, dot, dot. I hope you don't mind. Combine like terms. Multiplying polynomials. What's the key word here for multiplying polynomials? Language. You have to bring some soap to class. Like they did in the old days. That's okay. It's early in the year. Yeah, distributive property. So like that 2x. Do you like the rainbows? You don't have to do those. That's just the thought process I'd like you to go through. So it's what, 2x cubed plus 8x squared plus 10x. And then the other ones just don't forget to distribute everything. Plus 3x squared plus 12x plus 15. And after that, combine like terms. May I move on? Product of binomials, for that, all you have to do is use distributive property. I don't know how they separate it. Product of conjugates. I feel like we talked about the product of conjugates, didn't we? What's the conjugate of A plus B? We check in with your neighbor. What's the conjugate of A plus B? The conjugate of A plus B is, everybody? A minus B. How about the conjugate of A minus B? A plus B. So is it fair to say every binomial has a conjugate? Does that make sense? Every binomial has a conjugate? Yeah. I'm not sure it would help, but it's just A plus B, the conjugate is A minus B. How would you put that into words, though? This, where a binomial sum becomes a binomial difference. A binomial difference becomes a binomial sum. But the product of the conjugates is always the same. So it's going to be A squared minus B squared. It's always going to result in a, what's that expression called? Difference of squares. You could use distributive property to get there, but it's a waste of time because we know the result will always be a difference of squares. So like A, when I see that, I'm very confident in saying that the product is, wait, are they conjugates? Are you sure they're conjugates? How do you know they're conjugates? You can tell by looking. One is a sum, one's a difference. The terms are the same. So it's just 16y squared minus 9. Done. Is B. Are those conjugates? Nice. So the result will be a difference of squares, but it's a little different here, isn't it? It's going to become 4y to the 6th minus 25. Oh my goodness. I really want to do a good job with these. We're gonna be a little bit behind. So I'm gonna adjust your homework again. Don't start on the homework until, give me at least 30 minutes after class, please. And I'll adjust the homework appropriately so that things that we don't do today, you do for next time's assignment. Deal? Because it's about time for us to get started. Oh, wait, is it? Is it? Oh no, 45, 8:45. 8:45 is when we're gonna get started. I think we have time to just finish today. I'm sorry, I got a little confused. My apologies. Square of a binomial. A plus B squared to A minus B squared. Do you already know what this is equal to? Would you check in with your neighbor? See if they already know what is A minus B squared.
For what the. Oh, yeah, I should.
How many terms result in both of these? How many terms result? 3. In other words, they're both going to result in a trinomial. The first one is going to be A squared plus 2AB plus B squared. The second one is going to be A squared minus 2AB plus B squared. Always. Yes, you could always break it down into a multiplication problem and use distributive property. But that's a huge waste of time. And too often you'll get the answer wrong. So we're going to practice using this form. So the middle term, in my mind, I think double AB. That's what goes on in my head. I'm going to do B first because it just seems like I want to do the sum first. I know the first term is going to be 25x squared. I know the last term is going to be 16. The middle term, I look at that, I say, in my head, I see 20x, and then I double that. Does that make sense? I see 20x, then I double that, which I know is 40x, and it's plus 40x. Done with that problem. So for A, I know the first term is 16p squared. I know the last term is 9. Would you just check with your partner about that middle term? Oh, 81. 81. The middle term, check the difference.
Minus 2.
On the count of three, let's hear it. 1, 2, 3. Minus 72p. Is there a question about where that came from? Should be a very pleasant process to get that middle one, as opposed to using distributive property. Distributive property is great, but don't overuse it. If it's not necessary, avoid it if you can. Cube of a binomial. Check with your neighbor. How are you going to do this? X plus 2 cubed.
Yeah.
So it's just like.
Yeah.
Okay. Should I just would this be good? Just x cubed plus 2 cubed? Do you think that was in a multiple choice exam? Do you think that would be one of the choices? Which choice do you think that would be? That's probably the first choice. And the most obviously correct once you know. So what's a good way to do this problem? If we don't have a formula, please do not make up your own formulas. We don't have a form to use to do this cube, sum of cubes yet. Yeah, at least you have a sequence. What do you think? Does that make sense? Yeah, I think about it like this. X plus 2 times we have that square in there. We know how to square things. So, and I like the smaller polynomial first. For some reason, for me, that just feels better. We know that x plus 2 quantity squared is x squared plus 4x plus 4. And now we use distributive property. So I'm going to say x cubed plus 4x squared plus dot, dot, dot. Because I know you know how to do it. And when it says standard form, do you know what that means? Means you start with the term with the highest degree and then just go down one by one. Do we do it? Do we do it? Yeah, we didn't get to fast practice, but I think we'll be okay. If you want to hang out after the quiz and do some of that practice, maybe that's. But speaking of quizzes,